All right, for each of these problems, you're going to try the problem on your own, hitting pause on the video, and when you're done, you're going to watch the video and see if you're correct. So right now, hit pause, try the problem on your own. All right, we're going to work through this problem together. So Trayvon goes to the batting cages and he uses 2 tokens for every 10 pitches. So it would make more sense to think about finding the constant of proportionality where we would figure out how much for 1 token rather than how much of a token for 1 pitch. So when I make my rate table, I'm going to think about our tokens is 2 and our pitches is 10, and we want to think about how many pitches for 1 token. Because the number of pitches depends on how many tokens I have. So we would see that we would get 5. So the constant of proportionality is 5, and that means that I get 5 pitches for 1 token. And I'm just reading that information right from the table. 5 pitches is 1 token. When we write our equation, we're looking for the connection between the 2 variables. So we're thinking about the connection between tokens and pitches. And from our unit rate, from our constant of proportionality, we can see that we're going to multiply by 5. 1 times 5 is 5, 2 times 5 is 10, and we would apply that to our variable. So if I'm using the variables in my rate table, it would be the tokens times 5 equals the pitches. But it tells us that the number of tokens they want us to say is x. So they want tokens to be x and the number of pitches to be y. So all I have to do is kind of replace it with x times 5 equals pitches. I'm sorry, x times 5 equals y. And we want to get in good habits. That would be the same as 5x equals y. All right, hit pause and try this one. All right, to solve this problem, I'm going to make a quick rate table, and it's comparing feet and tiles. And for every 2 feet, he places 8 tiles. So I would want to think about how many tiles he would need for 1 foot. That would be the constant of proportionality that would make most sense. The number of tiles that I need depends on the feet. So I would want to figure out how much for just 1 foot. And we can see that we would need 4. So my constant of proportionality is 4, and when I read the information in the table, it would be 4 tiles. So 4 tiles for every 1 foot. Okay? All right, now when we write our equation, again, we're trying to connect the 2 variables. So we're looking for the connection between feet and tiles. And our connection is timesing by 4. Okay, so if I'm thinking about it with what's in the problem, I would think the amount of feet times 4 will give us how many tiles we need. But when I read the problem carefully, they're saying the length of the hallway is representing x. So it's going to be x times 4, and the number of tiles is y. Good habits, we would have it as 4x equals y. All right, hit pause and try this graph. All right, from our graph, I'm going to make a rate table. We're comparing scoops and sundaes. And I can tell us that the scoops is on the x-axis and the sundaes is on the y-axis. So that means that the x-axis is our independent. So that's the one we'll want to get down to 1. We always want to think about 1 on the x-axis. Now in this graph, it's hard to tell exactly what it is if I look at just where the 1 is. I don't know for sure where that is for the y-axis. So I'm going to use a point that's really easy to read. So I'm going to look at this one instead, where I can easily see that 3 scoops is 1 sundae. I would want to get down to 1 scoop. And that would give us 1/3. So I would say 1/3 of a sundae per, or for 1 scoop. And when we write our equation, we're looking for the connection between scoops and sundaes. So I would say scoops times 1/3, because that's how we're getting from 1 to 1/3. 1 times 1/3 is 1/3, would give us how many sundaes we have. And now I'm just going to replace it with my variables. So scoops is my x, and sundaes is my y. And then I would want the number to come first. So I'm just going to reorganize it. All right, hit pause and try this problem. All right, this problem is comparing time and cost. And from our graph, I can see this nice point is 1 hour is $8. And that's as far as I need to go, because I figured out how much it is for 1, which is what our constant of proportionality is. It would be $8 for 1 hour. I'm just reading that from the table. I'm looking at what those labels represent. With our equation, we're going to want to look for the connection between time and cost. So we want to think, how does time relate to cost? And I would see that 1 times 8 is 8. So I would say time times 8 is our cost. And then I'm just going to replace it with variables. So I'd replace it with the variables. Time is our x-axis, so x times 8, and cost is our y. And then good habits would tell us that the number comes first. So 8x equals y.